Well, thank you again for having us. Um, as I said, we're going to have a chat about sort of recent rainfall and temperature patterns in your area, but we're also Hugh's going to spend a minute telling us about the exceptional rainfall event we saw, over Ingham at the end of January, beginning of February, and I'm going to spend a little bit of time talking about the dry conditions we've seen across southern parts of the mainland over the past year. And then we'll look at how those rainfall and temperature patterns have impacted soil moisture and water storage. And then Hugh's going to take us through the long range forecast for March and April. Then I'll have a bit of a chat about some of the broader climate influences on the system at the moment and where you can find more information. So starting off looking at rainfall over the last 3 months. So there's a map for November on the left, December in the centre, and January on the right. And you can see that November has got a lot of blue in that map corresponding to above average rainfall, across most of southern Queensland and a lot of northern New South Wales. However, it was a bit more typical for November around places like Armidale, that sort of white area. Then in December, things were a bit mixed. Still a lot of areas around the border was near average rainfall, but you can see up the coast in Queensland, it was a bit wetter than usual. And then further down sort of the coast in New South Wales and northeast New South Wales, there was an area that was a bit drier than average. And then in January, it was more closer to average, around sort of Moree and Gundawindi and that sort of border area. Now, you'll notice in that November and December map, some of those same areas that had that sort of medium blue shading in Queensland, had 2 months of very much above average rainfall. That middle blue shading, that corresponds to rainfall that's in the wettest 10% of the historical range. And when we roll those 3 months together, that's what rainfall looked like for November through to January. So you can see, sort of northern New South Wales around Moree was pretty close to average. But across the border, generally speaking, things were a bit wetter towards the coast. And now this is February to date. And you can see these areas with sort of orange on the map are still sort of haven't quite reached their monthly average yet. And you'll notice for some parts, sort of in southeastern Queensland and northeastern New South Wales along the coast there's some parts that haven't sort of reached 40% of their typical February rainfall and are about 2/3 of the way through the month. So on this next map, it's including the rainfall that we've had in February, but also the rainfall that's on the forecast. And you can see for a lot of northern New South Wales, rainfall is tracking pretty close to average for February, and so too for parts of southern Queensland. But you'll notice those areas sort of on the east, or for Queensland at least, they are tracking a bit drier than average for February. Hugh, would you like to take us through that exceptional rainfall event?
Yes, thanks, Jonathan. So, like Jonathan says, exceptional rainfall for parts of Queensland focused around Ingham. And it was a combination of things that we saw here as the monsoon trough was active over Queensland, but actually not over the Northern Territory. And officially, we didn't declare the start of the monsoon until after this rainfall event. It's a combination between that trough and tropical low 13U and another tropical low as well. And we saw days and days of rainfall impacting this small part of coastal Queensland. Actually, the wettest February on record on the right-hand side, we can see from an internal monitoring map there, wettest February on record for stations with more than 50 years of data. So a 50-year data span, and this is the most rainfall we've recorded in February ever. It's quite a lot of rainfall. We saw over 2,000 millimeters, particularly focused around Ingham. We can see on that map on the left there, that purple color on the map is 2,000 millimeters of rainfall. And that all fell in the space from about the 28th of January, the last couple of days of January, into the first 8 or 9 days of February. So about a 10-day spell with over 2,000 millimeters of rainfall. The highest that we recorded was at Paluma Ivy Cottage, and we saw 2,611 or so millimeters. Now that's a record for that site, surpassing the previous one by about 400 millimeters. And this amount of rainfall was roughly equivalent to the significant flooding that we saw in 2019. And if we talk about it in terms of what we normally see at this time of year, it was roughly 3 times the monthly rainfall in the areas between Ayr and Tully, and 5 times the normal monthly rainfall that we see between Townsville and Lingham on the coast there. So very, very significant rainfall for that part of the world. That's what I think I have to say for that, Jonathan.
Thanks, Sue. Now, in contrast to that sort of short, sharp, heavy rainfall event, something else that's been sort of notable this last year is just how dry it's been across southern parts of the mainland, particularly since February last year, February 2024. So the map on the left there is showing you the rainfall pattern from February last year all the way through to the end of January this year. And you can see that for your area, it's generally sort of average to above average rainfall for those 12 months. But in the south, you can see we've got that band of red corresponding to below average rainfall across parts of southern WA, most of the agricultural areas of South Australia, and a lot of Victoria too. Now, the map on the right is the map that we use in our drought statement. It really just highlights areas where they've had those rainfall deficiencies. And there's a couple of different shadings there. That middle red shading, that's areas that have had rainfall in the driest 5% of their historical range for any February through to the following January period. And that's using data going all the way back to the year 1900. But those the areas with the dark red shading that you'll see across parts of South Australia's agricultural areas, that's actually lowest on record. So we've never had sort of that 12-month span being quite as dry as this in data going back to 1900. We've had other sort of years that were similar, but nothing quite as bad as this one for those regions of South Australia. And when we ask why has it been so dry there? Well, there's sort of 2 factors. One thing is that natural variability. Rainfall can sort of really shift from one month or one year to the next, but there's also a trend. Now, the map on the left is a map that comes out of the Bureau and the CSIRO State of the Climate Report. And what that map is showing, it's comparing the most recent sort of 30 years of rainfall to all the previous years of rainfall back to 1900. And what it's illustrating is that over the last few decades, we've seen this decline in cool season rainfall across the southern mainland, notably parts of Victoria, South Australia, and WA. And it's the cool season, it's that April to October season where we've noticed the most significant shift. And on the right, I've got that same period, the April to October rainfall, just for last year, just for 2024. And you'll see there's pretty good alignment between those patterns across southern Australia. You can see that last year's cool season rainfall for the south looks a lot like that trend pattern for the last 30 years. You'll see some other differences for other parts of the country, notably northern New South Wales and southern Queensland. Looks like sort of last cool season sort of bucked the trend. There's areas with above average rainfall, and that's part of that variability I was talking about. But for those southern areas, it looks a lot like the trend we've seen in recent decades. Now, at the same time, we've had pretty warm temperatures for a lot of the country, including your area as well. So we've got some maximum temperature maps in the top row, and then some minimum temperature maps in the bottom row. And you can see that, most of that southern Queensland, northern New South Wales, or the eastern part of it was warmer than average for all 3 months. In January, temperatures were a bit more typical for some parts of the east, where we've got that white shading. And you'll notice that the minimum temperature maps, the ones in the bottom row, they're even a bit more extreme. They've got more areas with that middle orange shading sort of very much above average temperatures in the warmest 10% of the historical range. But we've also got patches with that dark orange shading, where it was actually warmest on record, where we haven't had monthly minimum temperatures that high before. And that's looking at data going all the way back to 1910. But you'll see that January, was a bit more closer to average for most parts for minimum temperatures than it was in November and December. And those warmer than average temperatures that we've had are really consistent with that climate change signal that we're seeing, not just in Australia, but across the globe. So on the left-hand side, we've got a time series of Australian temperatures. So this is data that's averaged across the whole country from 1910. And you can see that from about 1950 onwards, there's a pretty clear warming trend in that time series. And Australia's climate has warmed by around 1.5 degrees since 1910. Now, illustrating the same thing on the right-hand side is a time series just for the mean temperature anomaly, but for Eastern Australia now, not for the whole of the country. And you can see again, it's got a very similar trend where we've got these red bars, these warmer than average years. We see more of those in recent decades, where we've got these cooler bars, those blue bars, those cooler than average years in the early part of the record. And again, you can see there's a pretty clear warming trend in that from about 1950 onwards. So really it's that climate change signal that's kind of loading the dice, if you will, sort of pushing us towards warmer than average conditions in our forecasts and in the observed temperatures. Now, having a look at some of the impacts that's had on soil moisture. So we've got a snapshot from the 20th of February, that map there on the left. And you can see for a lot of that eastern border region, sort of northeast New South Wales, southeastern Queensland, soil moistures are close to average, a bit drier than average further west. But you can also see there's a mixture. There's a few patches of above and below average rainfall there in parts of the east as well. And you'll notice further north, it's more broadly soils are wetter sort of than average across parts of northern Queensland. Now, on the right-hand side, we've got the soil moisture forecast for March. And so you can see there's more areas there on the map that have sort of below average soil moisture expected. And that's really a combination of the temperature and the rainfall forecast that Hugh will show you soon. Now on this map, we've got some information about storages or storage levels. Each of the circles here is a dam or a storage, and the size of the circle corresponds to the capacity or the volume of the dam, and the colour corresponds to how full the storage is. So you can see that along the coast, sort of in southern Queensland, we've got a mixture of sort of those green and dark blue dots. So some of those smaller storages at or near capacity. But you'll notice sort of south of the border in northern New South Wales, we've got some of those bigger storages that are only half full. And then further north in Queensland, you can see as well, there's a bit of weakness where we've got some areas where storages are sort of less than half full. Looking at water storage across the basins, if we concentrate on the eastern part of the map, to the Murray-Darling Basin, you can see we've got it split there into north and south. You can see that northern parts of the basin, currently storages are at 58% full, a little bit down on where we were the same time last year at 66.5%. But there's a bigger drop in the Murray-Darling Basin south compared to where we were last year. So currently sitting at 63.6%, bit over 20% lower than where we were at the same time last year. Now, looking at the capital cities just for a moment, you'll see Brisbane, which is second from the left at the top. It's actually, the storages there are sitting a little bit higher than they were at the same time last year. And most of the capital cities have fairly high storage volumes, the storage levels. The exceptions really are Perth and Adelaide. And if you look at Adelaide, that's the map, that's the plot in the top left, you'll notice not only is it sort of less than half full, it's actually got a bit of a gap from where we were last year as well, about 20% lower storage levels than this time last year too. Now, Hugh's going to show you the actual long-range forecasts.
Thanks, Jonathan. So the maps we have here are showing the long-range forecasts for March. And if you've not seen these maps before, they are the chance of above median. So it gives you the probability of rainfall and temperatures exceeding or coming in lower than the median values. It doesn't tell you anything about how far above or below median, just the probability that it'll be either side of that normal level. Now, for rainfall, we run from a scale into the lower probabilities in brown colours, and the high probabilities are in the greens and blues. For the maximum and minimum temperatures, then you're looking at reds as the higher probabilities and blues as the lower probabilities or the higher probability of cooler than the median conditions. Now, these maps are available on our website. You can look at them and they're updated every week. So it's important to keep up to date with them because this is the forecast now, but the forecast will evolve as we move through time as well. And we can see for the temperature map on the left-hand side, there's quite a neutral signal, really. There's not a strong colour on there for a probability either way. There's kind of more greens on there than anything. There's sort of green and white mix. So we're on the slightly increased probability of seeing wetter than average conditions across the region through March, but it's not strong probabilities there. Maximum and minimum temperatures, though, do show a much stronger signal for above median, particularly the minimum temperatures. They're very, very likely to be above median, whereas the maximum temperatures may be not quite as high probability there, but there is still very likely to see the maximum temperatures exceeding the median value. If we move on to the next slide, we can look at April as well. Now, the rainfall probabilities, you can start seeing some browns creeping in on this map as well, but it's quite a mixed bag across the area. You've got a few greens, you've got some whites, and you've got some browns. So the forecast doesn't show a strong trend either way, really. But the important thing to know is that this isn't a forecast for median conditions. It's not a forecast for average rainfall either. It's just there's not a strong probability either way in the rainfall. And I'll try and explain that a little bit more in a minute. Whereas the maximum temperatures, again, we're saying likely to very likely to be above the median, and the minimum temperatures very likely to be above the median. And if we go to the next one, now it's not just our model that's showing this trend as well. These maps are available from the Copernicus free climate forecast service. So you can Google this and have a look at the Copernicus multi-model ensemble. And what we have here is the ECMWF map and mixed with the Meteo France. So it's the multi-model ensemble. It's the mixture of all the major global climate models giving us the forecast here. And we can see it's a pretty similar forecast to the Bureau's model. Okay, so there's those slightly increased probabilities in green for an increased chance of above median rainfall. Whereas then when we move to the next month, April, we start seeing a very neutral forecast there. So that gives us confidence in the forecast on the Bureau model, and it shows that all the major climate models are showing a similar forecast for this period. If we move on to the next slide, please. Now try and quantify this a little bit. So those maps didn't show us the spread of solutions. They didn't show us how much above median it's likely to be or how much below median it could be. Whereas this map does here. This is for Goondiwindi and for Moree. So it's a point forecast. And this again is available on our website. You can click a point on those maps and then you click the plume symbol in the middle, that kind of in between the bar chart and the little graph symbol where you look at rainfall on the top, and it will give you this 5 months forecast, and it will give you the spread of solutions from the climate model. And you can see when we move into March, you've kind of got anything really from about 2 millimeters to about 120 millimeters for Goondiwindi, and it's a similar spread of solutions for Moree as well. Yes, they're kind of clumped around the median, but there is a large spread of possibilities with these. So it shows there's a large spread of outcomes in the rainfall. And when we go back to the maps that Jonathan showed for recent rainfall, sorry, if we can just think back about it really if we want to, but rainfall across this area in particular, and across a lot of Australia, is quite convective in nature. And what I mean by that is it's not borne out by large frontal systems. It's not uniform rainfall like you might see on the west coast of Tasmania or the west coast of Ireland or somewhere like that. It's very much thunderstorms and troughs, and it can be quite different between two areas that are quite close together. And we saw that in the February rainfall. There's some areas that have already exceeded their monthly median and some areas that are 40% of their monthly median. And that's the challenges of forecasting rainfall, particularly for inland Australia. The East Coast is a little bit more uniform. And in this part of the world, it's very much storm driven and very variable in its nature. So the important thing to note from this is that we should, although there is some increased evidence for above median rainfall, that rainfall is likely to be quite hit and miss, and there is a spread of solutions, and some areas may see above and some areas may see below. And we need to take that in mind when we're planning for the rainfall forecast for this coming season. Now, if we move on to the next slide, please. Whereas the temperature forecast is much more uniform. There's much less spread in the possible outcomes for the temperature forecast. And it's much easier to forecast the above or below median signal for temperatures. And actually, when it comes to climate change, pretty much every year we're likely to see above median temperatures now compared to the last 30 years, the average of the last 30 years anyway. And when we look at these graphs here, we can look at March, April and May. Pretty much all the solutions are coming in at the lowest range around the median, whereas the bulk of the solutions are above median. So we can be quite confident in that median to above median signal, particularly at the start of the season. There's a very high confidence that we're going to see at least median and likely to very likely above the median maximum temperature across this region. If we move on to the next slide, please. And we can visualize this as a chance of unusually high temperatures. So this is the chance of being in the top 20% of the historical range, so the top quintile. Now, the darker reds are higher probabilities or a higher number of chances of seeing that unusually high maximum temperature. And we can see across the region with 2 to 2.5 and 3 to even 3.5 to perhaps 4 times the likelihood of seeing above median maximum temperatures for the March to May period. And then when we look at the minimum temperatures on the right hand side, that signal's even stronger, with 3.5 and 4 times the likelihood of seeing unusually warm minimum temperatures. And that equates to 4 times the likelihood is equating to an 80% chance of seeing unusually high minimum temperatures. But I mean, that's the darker reds, but we're at least 60% chance of seeing unusually warm minimum temperatures. So it's likely, it's very likely. Now, if we move on to the next slide, please, I believe I'll be handing back to Jonathan.
Thanks, Sue. Now I'm going to just spend a minute or two talking about some of the influences on the broader climate state. And one of the remarkable things from the last couple of years is just how warm sea surface temperatures have been globally. So on this time series, all those grey lines are the daily sea surface temperatures from 1982 through to 2023. And it was actually in 2023, it's the light grey line that's sort of at the top of all the others. It actually sort of from about sort of towards the middle of autumn sort of shot above the rest of the pack and was kind of record warm with quite a bit of a gap between it and the previous warmest years. And it maintained that sort of elevated, those elevated temperatures all the way through 2023 and into the beginning of 2024, which is that orange line. And it wasn't until about halfway through last year that those record high temperatures actually dipped below the same point they were at in 2023. But since then, it trailed pretty closely to those same levels of 2023. And then you can see the beginning of this year, 2025, that's the red line. It's not warmest on record. We were warmer on record. We had warmer global sea surface temperatures last year, but you can see we're running a pretty close second place. And you can see again, there's a pretty big gap between those orange and red lines and the other grey lines below it. So record warm by a reasonable margin. And you can sort of see that in this map. This is a recent map of sea surface temperature anomalies. So all the red areas are sea surface temperatures that are warmer than average. The blue areas are where it's cooler than average. And you can see that generally there's a lot more red on this map than there is blue. There's a few other features you can make out here. You can see in the equatorial Pacific, we've got that blue signal. That's sort of a La Nina-like pattern where we have cooler than average waters in the central Pacific, and we have sort of warmer than average waters building up in the west. You can see in the Indian Ocean, there's not really much of a gradient between the east and the west. And you can see sort of off northwestern Australia, we've got some cooler waters there now, thanks to some mixing from the sort of tropical cyclone that we've had. Previously, we had some very warm waters off the northwest, but you can see that still waters off sort of central western WA are still much warmer than usual, as well as sort of in the Tasman, east of Tasmania, we've got some quite warm anomalies there too. Now, in terms of our sort of big climate drivers, the El Nino Southern Oscillation and the Indian Ocean Dipole, they didn't really have a strong influence on temperature or rainfall patterns across Australia last year. Some of the models were keen on La Nina earlier last year, but you can see in that top plot, the dashed line are the observed temperatures. Mostly we had sort of neutral or ENSO neutral temperatures in the region that's an indicator for us. But you can see they're edging towards that blue band, that La Nina threshold, sort of around that borderline minus 0.8 temperature. But then all the colourful lines, they're forecast from the different international agencies. And you can see there's generally agreement that we're likely to see that index that begin to warm up again and move sort of closer into that neutral range. So we've got sort of a La Nina-like pattern in the oceans, or have had for a little bit of time, but we didn't see much of a reaction from the atmosphere. And it's likely that this sort of won't be classified as a full-blown La Nina event. And it's likely that we'll see a return to a more neutral sea surface temperature pattern through autumn. Now, at the same time, that chart in the bottom, that's showing us the Indian Ocean Dipole Index, and the dashed line are the observed values of that index. And you can see towards the end of last year, we sort of dipped down into negative Indian Ocean Dipole territory. Whether or not it'll be classified as an event, I think is still to be sort of decided, but it came pretty close. But you can see since the end of last year, that index has become more neutral. And again, all the colourful lines they're the forecast from the different international agencies. There's pretty good agreement that that's going to remain neutral across autumn. Now, as Hugh explained before, some of that neutral rainfall outlook, some areas have sort of 50-50 chance of above or below average rainfall, but they're not guaranteed to have near average rainfall. So on this plot, we've got all the rainfall, the winter-spring rainfall from every year back to 1900 through to 2016, and then we've ranked them from driest to wettest. And then we've gone in with the texter and we've coloured in any of the years where we didn't have a strong push from our climate drivers. We call them neutral years. So that's all the blue columns. And you'll see that even in sort of neutral years, we don't have a clustering right around the median. There's quite a bit of a spread there. we're generally not likely to be in the sort of the tails. We're not likely to be sort of in the driest 10 or the wettest 10 years, but you can see that those neutral years aren't all bunched up around the median. There's, a handful of years that are quite wet, even though our drivers were neutral, and a handful of years that were quite dry across the Murray-Darling Basin. Again, even though our big climate drivers weren't sort of giving us a push towards drier than average conditions. Now, most of the information we've shown you today is available on the Bureau's website, but there's a lot of content on there, and sometimes it can get a bit buried. So on the left, that's a screen capture of the Bureau's homepage, and just below the forecast for the capital cities, there's a series of boxes. The first one in the top left is agriculture, which is worth having a look at. There's a really nice rainfall accumulation forecast there, which sort of shows you how much rainfall you're likely to accumulate over the coming week. But the one we're mostly interested in is that second panel from on the top left, which is climate and past weather that I've highlighted there with the red circle. And when you click on that, you come to sort of that climate landing page. And the recent rainfall maps and temperature maps that we were looking at before, showing us the recent conditions, there's a link to those called sort of recent rainfall. And then the forecasts Hugh was talking us through before, they're just next to those. That's the circle around the long range forecasts. The longer term trend information, that those climate change trends, you can find more information about those in the State of the Climate report. There's a link to that report sort of towards the bottom of the page. And if you're interested in getting monthly, seasonal or annual summaries for your state or territory, there in the news and reports section, there's a link to that on the left-hand side. That's also the area that you'll find the Bureau's drought report that's issued once a month, which has those rainfall deficiencies maps and has some commentary about areas that are enduring very low rainfall. Now, as Hugh was saying before, when you go to that long range forecast section, you can see the forecast maps. We have maps for sort of week 2, which is the period after the sort of the 7-day forecast. And we also have fortnightly maps, monthly maps, and 3 monthly maps, seasonal maps. And we have those for the chance of above median, which were those forecasts we were looking at before, that sort of 2-category, what's the sign of the rainfall or the temperature going to be. But we also have maps for the chance of extremes, like those temperature ones Hugh was showing before, where you can see what are my chances of being in the warmest 20% or the coolest 20% of the historical range. There's some outlook scenarios based around confidence levels. There's also some maps that show you the chance of having at least a certain amount, and you can select that amount. There's also one's called chance of 3-day totals, which is, I guess, is what we think of as sort of as burst rainfall. What's the chance of having sort of an exceptionally heavy rainfall event, even if it's over a couple of days? Then we also have the historical averages. So how do these medians, how do they translate to what your normal rainfall is? And at the bottom of that panel on the left-hand side, there's a link to past accuracy. And this is a particularly useful one because these long-range forecasts, generally, they're not as accurate as the 7-day weather forecast. They don't have that same level of precision. And typically, the further ahead we're looking, the less well the forecast model performs. So it changes for different areas through different times of the year. So in the south, often we've got more predictability when we've got a strong push from our climate drivers in winter and spring. And in the north, often there's sort of better predictability in some of the warmer months of the year. So those past accuracy maps are a good guide to see how well has the Bureau's model done for my area at this time of year in the past. So to summarise, rainfall was mostly average to above average during November to January for northern New South Wales and southern Queensland. But as we saw in February, some parts closer to the coast are still lagging behind. They have less than half their monthly average with about a week to go. Some areas that are doing better than average, but some parts that are a bit drier. And so that soil moisture map in the centre, sort of illustrating that the root zone soil moisture is close to average right now for much of that eastern border region, but still drier than average further west. And looking ahead, we've got slightly increased chances of above average rainfall for patches of southern Queensland and northern New South Wales during March. So it's, as Hugh was saying, it's a forecast that doesn't have a very strong signal in it. For some areas, there's a wide range of potential outcomes. And then the forecast for April, well, the signal was probably even looking a little bit weaker. And for some parts of New South Wales, there was an even indication there was sort of slightly leaning towards some drier than average conditions. Thanks very much for giving us your attention. We're happy to take any easy questions you have now, but we're also happy to take questions after this meeting to our email addresses, especially if you've got some curly ones that we need to take on notice.